And now on to defining our queries. Earlier mentioned I want to make recursive queries and geospatial queries, and for that purpose I'll create an interface for instance methods and an interface for static methods. Instance methods will have descendants and parents. It will be similar queries, similar recursive queries, but in other directions. And I'll also take care that the level of recursion is returned. Let's rather make it an interface. Application level. Okay. Just a sec. Now, rather have it like this. Okay. And this interface implementations will cover recursive queries, but I also want one geospatial query. And it will be called in an interface allocation model. That's an extension over model of allocation. And I'll call it nearby. Nearby takes latitude, longitude, and by the way, decimal latitude and longitude, and distance in kilometers. And it returns a location. Okay, let's make another type. Location. It will return a location array with appropriate distances. And distance is a number. Okay. As for implementations, let's first implement instance methods. So we'll implement descendants and we'll also implement parents. But let's first implement descendants. To be able to run a recursive query, you need an aggregate pipeline, and an aggregate pipeline will be one of the steps will be a GraphLookup. So it says here, starting point is ID, and ID connects to parent. Depth field is marked as a level, and if you want to be extra safe, you can specify end of recursion. For example, if you defined a location that has a parent of self, you would have an infinite loop, but maybe not specifying max depth would help indicate an error in your design. So I'd like to leave it out. And descendants field will be a top level document. So to be able to make it to top, I need to unwind them first. And replace root. And new root will be the result of a graph lookup. I forgot the first case of pipeline. Since this is an instance method, this query has to be in relation to the instance of a location. So this should always be the first case. Okay. So as for parents, it will be a similar query, but in opposite direction. So instead of starting with an ID, we'll start with the parent. And parent connects to ID. Result of a graph lookup will be called parents. And same thing, we want to make parents as a top level of the document. And we can achieve it with unwind and replace root. Next, on to defining a static method. Our static method is called nearby. And it receives distance in kilometers and the latitude and a longitude. Okay, so it will be another query. And another aggregate. And it will contain just one pipe. It's a geoNear. So everything that's near these coordinates. So I don't know if I mentioned earlier, but in a GeoJSON, specification is always that longitude comes first. Result of geoNear will have also a distance field. Minimum distance that should be specified is 0. You can go for any positive number. And as for distance kilometers, they need to be turned into meters. And geoNear looks up into geometry field. Why? Because geometry field has an index of that's called to the sphere. If the index is not there, I'm afraid this query wouldn't work. And it's a spherical query. So what it means, is include any of the documents whose coordinates are inside the radius of max distance. Okay, so I need to change the export. It's not enough to export as a model allocation because I couldn't access my static and instance methods. So I created earlier allocation model. And the allocation model is a compiled schema, and this should be added also. What else? Our slint compiles. So I'll add another rule in slint. Let's see, because I don't want it to complain. So let's see what it complains about. Where was it? Okay. So let's see if the linter works. And test should also work because nothing has changed. Okay, all the tests pass, but my coverage is a little bit less because I added additional code. So let's create another test. And our test will test our locations model, our queries. But for this test, I need the previously installed MongoDB Memory Server. So first off, I'll create a utility. Utility is called dbconnect, and dbconnect creates and caches Mongoose connection. So if the connection is already there, it's the register in the global scope. And if it's not already there, we connect to the Mongoose or otherwise MongoDB server, in our case MongoDB Memory Server, and register that promise and MongoDB connection to the global scope. And this is not enough. So describe test case should have a before all setup. And what the before all does, it connects to our database. We don't have populate yet, but we'll have it in a second. And after all, what it does, it clears the global scope, deletes all connections, and finally closes our connection. Okay, so now I'm missing a populate. And populate is command that just registers, inserts our test fixtures. Okay. And for this test case, I'll create a single country, 3 cities, and 3 districts. So let's see what the populate says. Okay, if I try to run the test, I think it should complain that there is no test case. Yes, my test suite should contain at least 1 test case. So let's make a test case. Okay. So Croatia is top level location, and it should contain all of the locations created below. So descendants should be greater than 0, but let's see how many descendants are run it in debug mode. Okay. So for this test case, Croatia is the top level location. So it should return all of the locations created after it as a descendant. So let's see in the debug mode what exactly it returns. Okay. So as I said, all of the locations created after Croatia are descendants. And for instance, Gripe is the last level location, a district, and it's on level 1. City is on level 0. Let's paste other test cases. You can check the code in the GitHub repository. I'll share the link after. Okay. So I explained the first test case. Croatia should contain all of the locations created after that. But Gripe, since Gripe is a district, it's the last level location and descendants for Gripe should be 0. The direction for parents is the other way around. So Gripe should contain a city and a country. So it's in city split and in country Croatia. So if I debug this test case, returns. Okay, as I said, it returns hierarchically. So it's in city split and in country Croatia, and parents are equal to 2. And for top level location, parents should be 0. And as for all nearby locations, so I picked up a spot, just a second. So Google Maps. For this location, I mentioned earlier, I created a city, Croatia, a country, Zagreb, and a district, Chernomorets, which is here. And for this test case, let's use a pinpoint over here. It doesn't matter because I want to copy these coordinates. And coordinates are copied here. The last argument is distance of 10 kilometers. So I suppose this location should return nearby 3 locations. First location is a country Croatia, because its center is in the capital city of Zagreb, where I put it. Next one is Zagreb, and next one is district Chernomorets. It's not in this district Chernomorets, but the query says, show me anything that's in distance of 10 kilometers. So let's see if I'm right. Okay, I'm right. So before committing, I want to run a linter and test. Okay, we can commit this code.